In this video, I show you how to set up an AI agent in make.com using Telegram as the front-end interface. I don't actually cover the Telegram setup in this video, but you can find a link to the Telegram setup video in the description.
So last time I talked about, I basically did an overview. I did AI Agents 101, and I talked about the structure of an AI agent. And these are the components that typically AI agent has in it. So you're interacting with the user interface. It talks to an LLM, which is like ChatGPT. The interface would be like your chat interface that you type your messages into, and it's interacting on the back end with the OpenAI API, the LLM model. It's maintaining state, tracking the conversation with memory and a knowledge base. So as you're having a conversation with it, it's keeping track of the context of your conversation. And then you have various tools that you interact with. So when you tell the bot to go do something, it knows which tools it has access to, and it goes and uses those tools. And then it can come back with a reply. The human in the loop can either approve or deny the accuracy of that reply. So you give it feedback on how it's doing. So that's how the agent is learning from its feedback. And I talked about, this is basically another representation of that, where you have a chat interface, you're talking to an LLM, it's maintaining state with memory, it has access to a knowledge base, and it has access to tools or other agents. And those tools can be APIs as well.
Thank you.
So the one that I'm putting together is this right here, but I'm doing it in Make. So I built this example in Make, and I'm going to demonstrate how this works through Telegram. I set up a Telegram bot that I'm going to use for the text interface, and we're going to be interacting with the director agent. And based on what we tell the director agent to do, it's going to delegate to these other agents based on the message. And then this whole machine here actually has access to state, which is the memory and the knowledge base. And I've got that represented by a Google Sheet. And then I'm simulating, I have two tools that actually work, but I'm simulating the others. And that's what's represented in this, which looks overwhelming, but I'm going to walk you through it. So I set up a Telegram bot. I have a Telegram interface here that's connected to this Telegram bot here. I'm going to type messages in here to interact with this animation. So I'm going to initiate a message in the Telegram bot. I retrieve the message. Each time a message comes through, I'm going to retrieve that message. Then I have a state situation here where if this is part of a previous conversation, so if you think of a message thread as one continuous conversation, this is basically going to determine whether or not I'm in a new conversation or I'm continuing the previous conversation. So each time a message comes through, I need to know if it's a new message or if it's a continuation from the previous message, because if I don't track that, each time I type a message, it's going to think it's a new conversation. So I do that by looking for this start message. That's basically how a new message thread is created in Telegram. So if I created a new bot window and I started a conversation with it, it would send this start message. So if it is part of a previous thread, I'm going to go retrieve that thread ID from the Google Sheet, because that's where I'm keeping track of the thread ID. You can see it here. So I'm actually just storing the thread ID here, and that's an OpenAI thread ID, which is a chat conversation. So then I'm retrieving it from the sheet, and I'm saving it in a variable. That variable is called thread ID. So that's the beginning of the conversation. I get a message. If it's a conversation that I'm continuing, I'm going to get the thread ID previous from the conversation that we've been having, and I've actually saved it from that previous message here. So that's how I'm maintaining state on whether or not we're continuing the conversation or we're starting a new conversation. And then just because of the way make works, when I set a variable off of a branch here, I have to retrieve it again to continue on along this branch. And that's just the way that make.com saves variables. So I'm saving the thread ID up here. If I don't retrieve it again, I can't use it down here. So I'm getting the thread ID down here. And then this actually it handles text and voice. So I can actually click on this microphone here and I can talk into my microphone and record a sound file that gets sent to the bot. So I actually have this where I'm able to detect if it's voice, if it's a voice message. So if it's a voice message, it's going to have a file ID. I'm grabbing that from inbound message here. Although normally when I click on that, that should light up, but it doesn't. So if I have a voice file, I'm actually going to download the voice file here from Telegram. Then I'm going to send that file over to OpenAI Whisper interface, which does the speech to text transcription. This is spelled wrong. The prompt is, please transcribe this. And I'm giving it the sound file that I've recorded in the bot. And then once I get the transcription back, I'm saving the text. This is OpenAI call. I'm saving that text, the transcribed text, into a variable called message. Again, because of the way make.com works, I have to retrieve that message because I'm coming off of this branch. So I've transcribed the voice file. I've saved the transcribed message. If it's a text message, I don't have to go through this process to download the file and transcribe it. I can just set the message again. That's kind of redundant in this case. I've set the message here, so I'm just getting it again in case this branch executes. Then I need to retrieve this one. I already have it over here, but I'm just going to get it again because it might take this path for the voice file. So I have the message. It's either a text message or it's a transcribed message from what I recorded using the microphone. And then I'm going to go ahead and message an assistant that I set up on the OpenAI side. That message is called, that agent is called Agent 99. I did that on the OpenAI backend. So this is on the API side. If you go to platform.openai.com and you've set up your OpenAI API key, you can go into the dashboard and you can create an assistant in here. It's an OpenAI assistant. And I just gave it this system instruction. You're a helpful assistant. Your goal is to manage a conversation through Telegram. That's all I did. And the reason I'm creating an assistant on this side is because I want it to use the same message thread. So again, if you think of a message thread as a chat session, it's the whole conversation that you're having with the chat bot. That can all be managed on the OpenAI side. And all I have to do is save thread ID that OpenAI gives me when I start the conversation. So the first call, I've set this message ID. It's actually nothing. So if you put nothing in here, thread ID, it's going to give you a new thread ID. So this is the first message in the conversation. If it's the first message in the conversation, it's going to create a thread ID. And that's what I'm tracking over here. So that as I come into the conversation again, at the beginning of this automation, I can grab the thread ID and continue the conversation from where I left off. And I think I can show you how that works, where state isn't maintained. It's not going to remember anything from the previous message. So like I tell it, hey, my name is Chris. And then on the next trip through, I ask it, what's my name? It's going to tell me it doesn't know my name because it doesn't remember the previous messages. Whereas if I just give it the previous thread ID in here, it's going to remember the whole conversation because it's on the same thread. So the prompt in here is, please respond to the user's message. The message is as follows. And this is the message that comes in that I'm typing in the bot. And then it says, if the message contains a request to complete a task or look up inventory. So I'm telling it to recognize when I'm asking it to complete a task or do an inventory lookup. I'm going to say, proceed your reply with, I'm on it, followed by a conversation that you're working on the task, and that you will end and will send a notification when the task is completed. So that's the instruction for the first message or the first interaction with OpenAI. So it's going to respond immediately with a response. So if I say, go look up this inventory item, it's going to respond and it's going to say, I'm on it right away. And it'll say, I'm on it. I'm looking up the inventory on this item for you. And I'll respond when I have the inventory information. So it's sending me a confirmation back to the bot saying exactly what I just said, just so that the user gets a reply right away. And then, like I said before, this is a new conversation. I want to save the thread ID. So I have this condition in here, identifies it as a new thread. If the message contains start, that means it's a new thread. I'm going to save the thread ID in this Google Sheet, which is this value right here. So if it's actually, that shouldn't be there. Oh, so if the message does not equal to start and reply from this assistant is I'm on it, we're going to continue. That means we've got a request for inventory or we have another task that's requested of us. So we'll continue. If I just say, hey, how are you doing? Since the message doesn't equal to start and the reply isn't I'm on it, it's not going to try to go through the rest of this automation. And these are where the decisions are made right here. So I can chat with this bot, and as long as I'm not asking any as long as I'm not telling it to complete any tasks, if I'm just chatting with it, it's not going to try to run the rest of these. It's not going to try to make any decisions. It's not going to try to execute any tools or look up any inventory. So that's what that route filter is. So if I am asking for inventory or I'm asking for a task, it goes to this director agent, which is represented right here. The director agent's going to make the decision on which of these guys gets the request. So the prompt for the director agent is, and this is just, I'm not talking to the original OpenAI assistant. I'm just doing a chat completion because I'm just going to make a decision here. I'm saying your role is to direct requests to one of the following manager agents. Here's a list of the agents and what they do. So I'm telling the LLM, you're going to be making a decision. You need to decide which of these agents, based on the request, which of these agents is going to get the request. So I've got a research agent that handles research requests. I'm telling the LLM basically what these do. I got a message agent that sends messages via email, text, or direct message. I have a scheduling agent that handles scheduling requests and calendar bookings. I have an inventory agent that answers questions about inventory. I'm saying, please determine which manager should handle the task and reply with your decision. So it's going to, based on the request, it's going to determine which of these it should get routed to. And they call this intelligent routing. One good example of this is, say I'll use a casino example. You've got a VIP player that's calling in, but the casino doesn't know when that player is calling if they're a VIP player. So you can have an agent identify the phone number they're calling from, go check the system, see if they're a VIP player, and if they are a VIP player, have them routed directly to a host. Have that call routed directly to a host so that the VIP player doesn't get caught up in the system with automated messages. They get personal attention right away. They get the VIP treatment right away. So that's an example of intelligent routing. Whereas every other call that comes in, if they're not VIP, we're just going to route them the regular way. But if they're a VIP, then we want a person to talk to them and give them special treatment. So the first agent is the director agent. It's going to route to one of these two based on that prompt. And I'm sending the original message that came in on the bot to this chat completion. It's going to make the decision. Then I'm storing the reply, which is the decision, in this variable. And then I'm going to route it accordingly to one of the other manager agents. So I've got the research agent, the message agent, scheduling agent, and this is the inventory agent. I didn't label that, but so this router has filters on these. It's going to look at what this director agent came back with, the message, And the message is probably going to contain, well, it will contain a keyword based on what this agent decided. So I've got either research, message, scheduling, or inventory. So I'm going to be looking for those keywords, and that's how I'm going to route to the other agent. So in this filter, this route, condition is the message has to contain the word research. So that routes it to the research agent. And this one, response message has to contain the word message. That routes it to the message agent. Inventory routes it to the inventory agent. And then each of these agents is going to make it, it's going to work the similar way. This director agent's going to determine which agent gets the request. That agent is going to get to determine which tool to use. So these are the tools. Well, they're agents attached to tools. So I've simulated. This one actually works. These are actually simulated. They're just variables. So I'm just going to reply with static messages here. So the research agent determines whether or not it needs to do a Perplexity search or a web search. So if I say in the message, I need you to do a Perplexity research on unicorns, it'll route all the way to this. Then based on that keyword perplexity, so if this agent says it's a Perplexity search, it will respond with perplexity in the message, because it's going to make the decision a similar way to the way that director agent did. I've got a similar prompt in here that says your role is to direct requests to one of the following research agents. Here's a list of the agents. You have Perplexity agent, you have a web agent. Please determine which agent should handle the task and reply with your decision. So based on the message that thing replies with, it's going to route to a Perplexity module to do the search. It says, please research the following. I'm going to pass the original message the user typed into the bot into Perplexity. I'm going to save the response here, and then I'm going to reply to the bot so that the user gets the message. And this always ends, all of these agents end in replies. I have it this way just so it's kind of easy to see in here, but normally I would just have a separate automation that handles the reply of the message. So all these agents work the same way. They're going to determine whether or not an SMS is going to be sent or an email is going to be sent based on request. So if I say send an SMS to Joe saying I'm going to be late, it's all going to be routed through the director. The director is going to determine that a message needs to be sent. The message agent is going to recognize that an SMS message needs to be sent. It's going to take this route. If I say send an email to Joe, it's going to take this route. And they're all filtered the same way. It's if the reply contains email, route it to this direction. If the reply contains SMS, route it to here. So they all work the same way. Scheduling is the same. Direct request to one of the following scheduling agents. It's going to be a Google Calendar agent or an Outlook Calendar agent. Same basic structure of the prompt. Same here. This one's a little different because when I get to inventory, really, there's no routing. It's just going to go check the inventory. So on this one, I'm just saying reply with one word that identifies the item being inquired about in this message. So if I say, how many widgets do I have in an inventory? It's going to reply with the single word widget. And I'm going to store that reply so I know I'm looking for a widget. I'm going to search the inventory. This is how you search a Google Sheet. I'm searching rows, whereas item in column A is equal to widget.
So
I'm
Chris,
basically,
in this example, you're assuming that this example is assuming you're managing your inventory in that Google spreadsheet or a Google spreadsheet.
right. I could add another branch here, the way I have it up here, where I could say if the user is asking you to search Google Sheet, route it this way. If the user is asking you to look it up in the database, I could add another route. So this is just specific to Google Sheets. Although this I'm queuing off of the word inventory, but I could add extra branches saying get inventory from a Google Sheet or from a database. Then once I find the inventory item, I'm basically grabbing the number from that inventory item. I'm passing it on to another ChatGPT completion. I'm saying, please answer the following questions from the raw data provided. The question is, this is the message from the bot that the user typed in. If I say, how many widgets do I have in inventory? I'm grabbing the raw data for widgets. So I've looked it up in the sheet and I have item is widgets. The amount is 1736. And then I'm having the LLM do the reply on that. I'm basically giving it the data and telling it to reply the user-friendly message. So I've got the response, I'm saving it from this, and I'm sending it back to the bot.
So I'm probably jumping ahead here, but in this process, you're not deprecating that inventory. You're just identifying it in the spreadsheet, but not impacting any movement.
You're just reading it. It's just read only at this point. But that could be another function. I could say, change this inventory amount for widget to whatever, and I could add another branch here and handle that. So I'll show you how this works. I'm going to go ahead and trigger this or turn this automation on, and I'll do the widget example if I can get the window small enough for you guys to be able to see the thing trigger. So I'll say, how many widgets are in inventory? See, it's running. It says I'm on it. I'm checking the inventory, and you can see it went down this path. I'll check the inventory for the number of widgets and get back to you with details shortly. It actually went faster than I expected. There are 1736 widgets in inventory. So that's right. I'm going to turn this on again, and I'll say, if I can get this smaller, please do a Perplexity search on Joe Biden. You can see it's right here. It should go up to this top branch. It's doing a Perplexity search. As I'm on it, I'll perform a search on Joe Biden, gather some information. I'll update these shortly. And then it came back with the information on Joe Biden. And then I can test for each one of these things. Let's send an SMS. I got to start this again. I'm just going to go ahead. I'll run it separate each time. Send an SMS to Joe, telling him I'll be late. There's the first message. I'm on it. I'll send an SMS to Joe, letting him know that you'll be late. SMS sent. And it routed over here to this message agent, routed to the SMS agent, and replied with SMS sent. Of course, you're going to want to put the tool in between these two that actually sends the SMS. What else? Oh, calendar. Please make a calendar appointment. Please create. I got to say Google Calendar. So it routed it Google Calendar task done. It said I'll create a Google Calendar event with a meeting with Joe on January 25th, 2025. So that's basically it. Question from Michael. Oh, that was your question from before, right?
It wasn't. Jumping back to when you had the whole setup and you were talking about the database. I think you answered this question answered that question throughout it, but I know I watched last week's call. You were talking about RAG, separate database. That was the heart of my question was, we're talking about a vector database in this example. It sounds like Google spreadsheet is serving that purpose for this conversation.
Yeah, we don't have a vector database in this example. Basically threw this together today, so I didn't have a chance to implement RAG in this.
Yeah, all that I was just trying to understand whether or not that was in play here. So.
Yeah, and you saw on how that works, basically how the RAG stuff works.
Well,
watch the call.
Yeah, I have to admit that I watched it on my mobile, kind of was moving, so I didn't get a chance to digest it. I know it was part of the discussion, but that's I want to go back to and understand that aspect better. So
if I cover that real quick. So creating a RAG system, you want to put your documents in a database. So you have in that document store, just a regular relay base, have the document itself, the raw file. You have the text representation of that document, and then you have the metadata that basically would tell the LLM what's in that file. So as you're preparing your documents, you want to clean them, make sure that there's no garbage in them, no garbage characters. You want to have a text representation of them because well, text and PDF. I think PDF is basically a glorified text document. And the way it's stored in the vector database is that text is chunked into pieces, and want to chunk it into sizes that whatever embedding model that you're using most efficiently at. So using OpenAI vector embeddings, there's a specific size that it likes and a certain overlap that it likes. So you chunk those into pieces of text, and then you have an overlap so that the LLM knows which the pieces go together. You're going to generate vector embeddings for each of those pieces, and that's basically going to be your index, those pieces. And then you store those in the vector database. So you have a vector index from the vector embeddings, and that's what's going to help you match up vectors from the query that are coming in. So the two vector indexes represent the relation from the query to the relation of the document pieces, right? So that's what's stored in the vector database. And typically have an index as well that refers back to this document store so that you can provide the original citation back to that document store.
Yeah, that makes sense. And this showing right now is probably a completely whole separate conversation. Just curious what exactly was being used here. These stores being represented with a tool or whatever it was. But in any case, you've more than answered the question. So thank you.
Yeah, and for make.com, well, for most of these, a lot of people use Pinecone, and this actually does have a Pinecone module in it. And then the other one is Supabase, which uses, there's no Supabase module. Oh, there is a module now. Oh, that's Super SAS. Have an example in here.
Yeah, when you mentioned Pinecone, that's exactly where my question was going. So
Postgres you use with Supabase. So Supabase has vector storage in it, and it can work with vector embeddings, but you use Postgres to retrieve from Supabase. So if you're putting together a make.com module, you're going to want to use Postgres module to retrieve from Supabase.
Okay, yes, thank you.
And the Pinecone module, here functions, so you can upsert, update, get a vector, query vectors, delete a vector, and then for vector indexes, I think, OpenAI has its own vector store as well, and you can use that one with an assistant. So that's what this is. Add file search. You can add files here. This will actually create a vector store when you add files to it. I don't think it works that well, but it operates independently of the automation. So if I attach files to this assistant, since I'm talking to it in this automation, it'll automatically retrieve files in that vector store that are related. So I don't even have to implement it here. I can just add it into the assistant on the assistant side. Just reading Wayne's comment. The questions? I know this is a lot. We'll provide this for you guys to play with if you want to try this out yourself. And I can also create a document that shows you how to set up the Telegram side. This actually could come in handy if you want to create a personal assistance. So you can use Telegram on your phone. You could message it and say, hey, go check my email and see if I have any important messages. Have it filter your email messages or trigger the lights in your house, whatever you want it to do. That's what I plan on using this for. So I want my own personal assistant to handle not only business things, but also home automation and whatever else. Oh, I didn't demonstrate this. Let me show you this real quick. Let's do a Perplexity search on unicorns. Oh, it didn't trigger there. Oh, that's the wrong one. I was talking to the wrong bot. Please do a Perplexity search on unicorns. So you can see up here, it's actually doing it did the transcription. Please do a Perplexity search on unicorns. That's doing the research. See it here. There's the response on unicorns. That's all the parlor tricks I have for today.
You initiated that unicorn or perplexity ray of voice. Can you have it
Yeah.
respond in voice as well?
I would
Okay.
responding with text here. I could go have to plug it into 11 Labs probably. So I could take this text. Actually, I wonder if I could do that now. I don't think I have 11 Labs set up.
I didn't mean to throw you off. I was just curious.
Yeah, to do the reverse. So basically, you take the text and you have 11 Labs create the voice file from it, and then you could return with the voice file. So yes, it can be done. All right. Well, thanks everybody.
Great call as always, Chris.
Yeah, no.
I'll provide this the comments underneath the video when it pops up tomorrow sometime. And then I'll also create a Loom to show you how to set this part up if you guys are interested in playing with this.